Hey guys, welcome back. It's Professor Hank, and in this video I'm going to show you how to compare pointers, and more specifically, more accurately, how you can compare the memory addresses stored inside those pointers, or compare memory addresses against each other. In addition to that, I'm going to show you a particular problem that you need to watch out for and how you can avoid it. All right, so let's go ahead and get started. So let's see an example of what we're talking about here. Let's say that we have an array. Okay, and I'll initialize it to 86753. Okay, and so we can use these relational operators with addresses, which means that we could retrieve the memory address of the first element of the array. We could retrieve the memory address of the second element of the array, and then we can compare those memory addresses, say less than, right? So we can have a test expression that's going to evaluate the true or false, right? Because what's going to happen is that this memory address that's retrieved, it's a number, it's a hexadecimal number, okay? It's an integer. And so the memory address retrieved here is also. So if the first element of array A has memory address less than the second element of array A, then this is going to evaluate the true. So, and that is true, right? Because the memory addresses of the array for each element, they grow, okay? So here you can say, yeah, that A0 comes before A1, right? If this is true, then that's what we're going to see. So let's test it and find out if that's exactly what we see, okay? So you can see that A0 comes before A1. And so we can prove that to ourselves by printing out the memory address of the first element, okay, and then the memory address of the second element. All right, and when we do that, we're going to see that the memory address of the first element is smaller than the memory address of the second element, right? In hexadecimal, 8 is less than C, right? Because 8 is 8, and then 9 is 9, and then A is 10, B is 11, and C is 12. So this evaluates to true, okay? So another thing we could do is we could, check to see, let's do a couple more examples. If the memory address of the first element is equal to A, right? What's in A? Okay, and remember that arrays are constant pointers, right? So the memory address of that first element of the array is stored in A, right? So the memory address of the first element should be the same as the memory address that's stored in A, right? So if that's the case, then we should see they are the same. Okay, and we can print out those memory addresses to prove it to ourselves. Okay, so C out A. Those should be the same, and we should see those because they are the same, right? So as you can see, right there in the output. Okay, so that would be true. We could also test to make sure that, say, two pointers aren't pointing at the same thing. So let us say that we created a pointer P, and we gave it the memory address of the second element, okay? Now what we could do is we could say, oh, well, if P does not equal A, right? Or the memory address of A0, right? If that's the case, we can say that P is not pointing to that first element, okay? Or if we were just to use A, we could say that this pointer P is not pointing to the first element of the array. Okay, so either way it works, as we demonstrated here, right? The array name itself is a pointer, but also, the first element, the memory address of the first element is going to be the same. Okay, so we can say, all right, well, P does not point to array, the first element of the array, to the first element of the array. Okay, it doesn't. It points to the second. And we're going to see that because this is going to evaluate to true. And we will print out the contents of P, and we will print out the memory address of the second element of the array. All right, so let's check it out. So P does not point to the first element of the array. Okay, and then you can see that P, okay, and the memory address of A1 are the same, right? So since they're the same, P doesn't point to A. Okay, now let's just print out the contents of A. Okay, you're going to see that they're different values, right? So P does not point to the first element of the array, right? Because P contains the memory address of the second element, and A contains the memory address of the first element. Okay, so as you can see, we can use all of the relational operators to ask all kinds of questions about where pointers are pointing, right? So we could also do something like this. So let us say, we got pointer P that is got the memory address of the second element of the array. So how about we create another pointer, we'll call it Q, and we'll initialize it with the memory address of the second element of the array. Okay, so we can ask a similar question. We can say, well, if P equals Q, right? We can say cout P and Q are pointing to the same thing. Okay. Else cout P and Q are pointing to different things. Okay, and that's what we're going to see. We're going to see that else clause kick in. P and Q are pointing to different things. Why? Simply because P and Q contain different values, right? So what do P and Q contain? Well, P contains the memory address of the second element of the array, and Q contains the memory address of the third element of the array. So you're going to see that those memory addresses are not the same. Okay, so one more thing you could do, and this was actually a question that I had on a interview question, right? It was a coding test for an interview, and they wanted to know if a particular pointer pointed to a location within an array. So how could you tell, right? Well, let us say that we have pointer R, and it's initialized with the memory address of the third element of the array, right? Well, if that's the case, then the memory address here is going to fall in between the memory address of the first element and the last element. So all we have to do is some basic range checking here. So what we can do is we can say, oh, well, if R is greater than or equal to the memory address of the first element of the array, and R is less than or equal to the memory address of the last element of the array, then we can say that R points to a location inside the array, right? And that's going to be the case. That's what we're going to see. Okay, so you can see right there, R points to a location inside the array. Okay, because why? The memory address of A2 is greater than the memory address of A0 and less than the memory address of A4. All right, so let me show you one more thing here. Now that you kind of got a handle on how you can compare memory addresses and use pointers to help you out with that, let's look at a potential problem. Okay, so let us say that, let's go ahead and create a couple of variables. We'll call one X and we'll call one Y. Okay, and then we'll initialize a couple of pointers. we'll call P, which will have the memory address of X in it, and Q, which will have the memory address of Y in it. Okay, so when we do that, P is now pointing to X and Q is pointing to Y. All right. Now, you got to be careful. Okay, so if you write a test expression like this, right, P equals Q. Okay, what are you comparing here? You have to be careful, and you have to understand that what's being compared here, this is comparing memory addresses. All right, memory addresses of what? The memory address of X and the memory address of Y, because the contents of P and Q are the memory addresses of X and Y respectively. Okay, pointers are just variables that hold memory addresses. So what this if statement is doing is this is asking the question, does P and Q point to the same thing, right? And the answer here is no, right? Because the memory address of X is going to be different than the memory address of Y. So we can have a little cout statement here, say cout, P and Q point to the same thing, right? Otherwise, we can say something like cout P and Q point to different things. Okay, and that's going to be the case. Why? Because the contents of P and Q are different. Okay, because their memory addresses are different. So just for reference, let's print out P and let's print out Q. And you'll see that they're different values. All right. Now let us say that we initialized both X and Y with 5, right? So this is still going to evaluate to false, because why? Because what's in P and Q are the memory addresses of X and Y, not the values in X and Y themselves. Remember, pointers, they're pointing to another memory location. Okay, so if you wanted to actually compare the contents of X and Y, well, then this isn't going to work, right? Because you're comparing the memory address of X and the memory address of Y. So, so we have to dereference, right? So we'll use that dereference operator. Okay, and then you'll be able to see that there's the memory addresses of the two variables, but then there's the contents of the two variables. Okay, so if we want to compare the contents of X and Y, then that's what we have to do, right? We have to dereference P and we have to dereference Q, right? So that is going to go to the memory location whose address is in P. Well, whose address is in P? X. Get the value out of it. What's the value in there inside of X? 5. Similarly with Q. Go to the memory location whose address is in Q. Whose address is in Q? The address of Y. Get the value out of there. Well, what value is in Y? 5. So now this is going to evaluate the true. Okay, so then the contents of what P and Q are pointing at are the same. Okay, otherwise they're not. Otherwise they're not. They are not. Okay, and it would be useful if I actually had a cout here. So let's put that there, and let's put this here. Right, so this is a little bit of a gotcha. You gotta be, you gotta know what you're doing here. P and Q are pointing at, I should say, are pointing at are the same. Okay, there we go. Let's do that again. Okay, and the contents of what P and Q are pointing at are the same. All right, so there you go. Okay, so that's going to bring this video to a close. If you're a student of mine, you have questions about any of the topics that were covered in this video, feel free to drop me an email, stop by my office hours, or hit me up on Zoom online. For the rest of you, if you thought the video was useful, please consider giving a thumbs up. If you thought the video sucked, you got the thumbs down button as well. Consider supporting the channel in various ways. You can subscribe, you can join as a member with additional perks for as little as 99 cents. leave a comment, whatever. But most of all, thanks for watching, and we'll see you next time.